Now, a quick check shows that the equation at hand is neither exact, separable, or linear. So we try to write it in the differential form. So note that. So let's try to write it in the form dy dx and see how function will look like. Now, this is the same as x squared dy equals to xy plus y squared plus x squared dx. So I've taken this to the opposite side. So to get dy dx, divide through by dx. So x squared dy dx equals to xy plus y squared plus x squared, which implies that when you make dy dx the subject, you get xy plus y squared plus x squared divided by x squared. Actually, a quick check on this right-hand side should tell you that both the numerator and denominator are homogeneous functions, because in the numerator, each term has degree 2, similar to the denominator. So this can be written as x y over x squared plus y squared over x squared plus x squared over x squared, which tells us that dy dx. Now, 1x and x cancel, so we have y over x. This can be written as y over x squared, and that last term will give us 1. So then with this, we can now fix, let v to be given by y over x, from which y is vx and dy dx. Now using product rule to this product of v and x functions, we'll get x dv dx plus v. So then now we use this and substitute the values in the differential equation that we have. So where this dy dx we replace by x dv dx plus v. This one by definition is v. This will be v squared and then plus 1. So this tells us that x dv dx equals to v squared plus v minus v plus 1. I've taken this one to the right-hand side. V minus v is 0. So this implies x dv dx equals to v squared plus 1. So multiply through by dx, so x dv will be given by x dv v squared plus 1 dx, and then separating variables, you have dv over v squared plus 1 equals to dx over x. Next step is just to integrate dv over v squared plus 1 dx over x. This one is a standard integral whose value is tan inverse of v. This will be ln of x, then plus a constant of integration. So which tells us that tan inverse, remember v is y over x, will be given by ln of x plus c. So we see that y over x will now be tan of now ln of x plus c. So which means that y alone will be x tan of ln of x plus c, and this will be the solution. Another question. Solve the equation dy dx equals to y over x plus x sine of y over x. Now this equation suggests that we need to do some fixing to enable us solve it. So we can say let v be given by y over x, so which is the same language as saying y is vx, which also implies that dy dx equals to x dv dx plus v. So with that substitution, we'll have x dv dx plus v equals to y over x is v, x sine of v. Now v and v cancels out, so this implies x dv dx equals to x sine v, which means that dv dx equals to x sine v divided by x. Now this means that dv equals to sine v, x and x cancels out, then dx. So dv over sine v equals to dv, dx. Now we integrate dv over sine v and integrate dx. Please note that 1 over sine v is the same as cosec v and then when you integrate cosec v, you get you get ln of which will be ln of tan v over 2 then plus equals to x plus c. So which means that v by definition is given by y over x. So we'll have ln of tan y over 2x equals to x plus c. Lastly, evaluate dy dx given by x plus 2y divided by 3y minus 2x. So actually this is homogeneous. So we let y to be vx, which will give dy dx is v plus x so that we have, replacing in this equation, we'll have v plus x dv dx equals to x plus 2 times vx over 3 times vx minus 2x. So v plus x dv dx give us, now you see x is common, so 1 plus 2v over x into 3v minus 2. So 1 plus 2v over 3v minus 2. So x dv dx 1 plus 2v over 3v minus 2 minus v. Now you can put all the values over 3v minus 2 to get 1 plus 2v minus v into 3v minus 2, which gives 1 plus 2v minus 3v squared plus 2v over 3v minus 2. So with that, we'll have x dv dx equals to 1 plus 4v minus 3v squared over 3v minus 2. So we separate variables by dv x equals to 1 plus 4v minus 3v squared over 3v minus 2 dx. Cross multiply by reciprocal of this and reciprocal of this. So we'll have 3v minus 2 over 1 plus 4v minus 3v squared dv equals to dx over x. So then now we integrate both sides. So 3v minus 2, 1 plus 4v minus 3v squared dv is the integral of dx over x. So left-hand side, we use substitution. Let u be given by 1 plus 4v minus 3v squared, which means, remember, this will be now ln of x plus c du is 4 minus 6v, then du. So which is the same as dv. dv equals to du over 4 minus 6v. Now 4 minus 6v can be written as 2 into 2 minus 3v, which can be written as negative 2 into 3v minus 2. So that now this will give us integral. So we can write this one as negative du 2 into 3v minus 2. So 3v minus 2 over u times negative du over 2 into 3v minus 2. And this cancels out. We have negative a half integral of du over u, which is negative a half ln of u. So we'll have left-hand side negative a half ln of 1 plus 4v minus 3v squared equals to ln of x plus c. Now multiply through by 2, or we can bring this to the left-hand side so that we have ln of 1 plus 4v minus 3v squared plus ln x equals to, let me say this is c1, say c, where c is the same as negative c1. Which we can write as ln of square root of 1 plus 4v minus 3v squared plus ln of x equals to c. So we'll have ln of x square root of 1 plus 4v minus 3v squared equals to c. Or we can say x square root of 1 plus 4v minus 3v squared equals to, actually I can write this one as ln of, say, another constant a. So I just say this equals to a. So that we can square and have x squared into 1 plus 4v minus 3v squared equals to a squared. But remember, v is y over x, since y is vx. So replacing, we'll have x squared plus 4vx squared minus 3v squared, x squared equals to a squared. So it'll be x squared plus 4x squared, v is y over x minus 3x squared, and then y squared over x squared, the place of v squared, equals to a squared. now will be x squared plus 4xy minus x squared and x squared cancels out, so 3y squared equals to a squared. Now, letting a squared to be just another constant, say k, we'll have x squared plus 4xy minus 3y squared equals to k. This will be the final solution.